Hello, in this video I'm talking about the next topic of the collection framework, that is called set interface. What is a set interface? Till now I covered the list interface. What are the classes that implement the list interface? There are four classes: array list, linked list, stack, vector. All information about these classes are covered in previous videos. And what are the method about collection framework contained, and what are the method contained by the list interface, I covered till now. If you are not watching that videos, please watch that videos, because if your basic concept is not clear about the collection framework, then you did not understand what are the going on in previous videos, in upcoming videos. So you have to clear your concept from zero to hard level, means zero to advanced level. So you have to complete the all information from basic to watching the video from lecture 1 to lecture last lecture of the collection framework. Okay, so let's get started this video. Before starting the set interface, I want to revise some quick revision of collection framework structure, how it will be structured. So there is no classes in this collection interface that are directly implement the collection interface. Means there is no classes that there is no predefined class that directly implement the collection interface. There are many different classes that implement its child interface. Means collection interface have only child interface. The child interface are implemented by the different classes. So collection interface have a three sub-child interface. First one is a list interface that I covered. Second is set interface. Third one is queue interface. So what are the property? What are the classes? What are the method contained by list interface? I covered. Till now I started the set interface. After completing the set interface, I started the queue interface. Okay. When we are complete all these three interface and its child classes and child interfaces, then means you are completed your collection interface. So this is all information about the structure, basic structure of the collection interface. So question is, sir, the main concept about collection is we are able to store the group of data in which we are not going to provide the some fixed amount of size of a group. Means if I want to store the data into a group, but we didn't know about how much data I want to store into that group. So for that I have to use collection framework, because by using the collection framework we are able to store how much amount of data in a group. We are able to do that without giving the fixed size of a group. So this is all information about the collection interface that are provided by the property of the collection interface. But some specific property are provided by the list interface and are little bit different from others interface that are provided its own specialization. What I mean by specialization means some specific functionality provided by the list interface, and other some specific functionality provided by the set interface, and other some specific functionality provided by the queue interface. This is why all three interfaces are different interface, and they are provided different functionality in the group of data. Okay. So I want to revise the concept and what are the functionality provided by the list interface into the group of data. So first property are provided by the group of data on the group of data by list interface is we are able to store the duplicates element into the group. If I want to store the duplicates element into the group, so we are able to do that by using the list interface object. Okay. Second property are provided by the list interface. We are able to store the null value. Third property, in which order we are able to we are inserted the data into the group in the same order in which we are able to store the data into the group. In the same order data are inserted into the group in the memory also. Means insertion order is preserved in the list interface, but some extra features are provided, some differences in the set interface as well as the list interface. So set interface property is, in set interface we are not able to store the duplicates element. If I want to create a project in which I want to store the group of data, in that data I didn't want to store the duplicates element, so we have to create the object of set interface. Okay. So set interface provides us to store the element into the group without repeated itself. Means duplicates element is not allowed into the set interface. First property. Second property is there is no fixed position of an element in which they are inserted. Means what I am saying, there is no fixed way of position of an element in which they are inserted. The meaning of this sentence is the insertion order is not preserved unlike list interface, because list interface provides us to store the data in which order we are inserted. In the same order they are inserted into the memory also. But when we are creating the object of a set interface, at that moment of time we are inserted into the group we are inserted the element into the group in which order they are not follow the same order in the memory in which they are stored. Means if I store the element 3 after 4, then there is no fixed chances for yes 3 is present before 4. There is no fixed chances. Means what I am saying, insertion order of element is not reserved. Okay, so these are some differences of set interface and list interface. So let's talk about some interfaces and sub classes that are implement and extend the set interface. The first property of set interface is duplicates element is not allowed. Second is insertion order is not reserved. Now in set interface didn't contain any new method. What I am saying, set interface is a child interface of a collection interface that extends the collection interface. But for example, list interface are contain few new method in his body as collection interface are contained. But when I am talking about the set interface did not contain any new method in his body. It directly inherit all the method that are contained in the collection interface in his body. Means set interface does not contain any new method. Okay, so there are some classes, there are some predefined interfaces that extend and implement the set interface. So first class that implement the set interface, that is called the has set class. What I am saying, has set class that implement the set interface, and has set class is have a child class that is called the linked has set class. Linked has set class is a child class that extend the has set class. Okay, there are two classes that implement the that implement the set interface. First one is has set class that directly implement the set interface, and second is the linked has set class that are extend, that is a child class of has set class. Okay, now some interfaces are that extend the set interface. Means set interface not only have a predefined classes that has set and linked has set, they set interface also have some sub interface, sub child interface. So first child interface is sorted set interface. Sorted set is a child interface of a set interface, and sorted set interface have also a child interface that is called a navigable set interface. Means set interface and it have a child interface that is called sorted set interface, and sorted set interface have also a child interface that is called the navigable set interface. At last there is a one class that is called tree set class. Tree set class is a class which implement the navigable set interface. Means tree set class we must have to provide the implementation of all the methods that are contained by the collection interface, as well as the sorted set interface, as well as the navigable set interface, and some new method of tree set also. Means tree set is a class which implement the method of contain its parents interfaces. Okay, so this is all information structure of the set interface. Means set interface have its own some classes that directly implement it, and some child interface that are implemented by the tree set class. Okay, so in this video I am talking about the set interface structure of the classes that implement directly the set interface. So first class that implement the set interface, that is called the has set class. So what are the property provided by the has set class? Has set class is a nothing. It is used for it provides specific functionality for creating the object of has set class. We are able to store the data into the has table. Means has table data structure are used for creating the class of a has set class. If you did not know about the has table data structure, so I am sorry, I am not going to in detail about has table data structure. But if you know about has table, so has table data structure are used for creating the class of a has set class. This class is used for the functionality, the core functionality provided by the has set class is it is used for efficient searching. Means there are a group of data in which I want to search efficient searching, fast searching. So for that I have to create the object of a has set class. We have to use the object of a has set class. Okay, so this is all information, and again some information and some property of has set class, that is duplicates are allowed because it implements the set interface. The duplicates are allowed. Null values are allowed. Third one is heterogeneous object. Means we are able to store the different data type in the same group by using the object of a has set class object. And the next property is we are able to store the null value also, and insertion order is also pre-reserved. Insertion order is not reserved like set interface. Set interface also does not provide the order in which they are inserted the element into the group in the same order, they are not stored into the memory actually. So insertion order of element is not preserved in the hash set class also. So this is all information about hash set class. There are some constructor which is used for creating the object of hash set class. So first object is that is in which we are not passing any argument into the its constructor. So by default the size of the hash set class in which we are able to store the data, that is the 16, and there is another component, another factor that is called the load factor. What is load factor? We know that in collection interface, when we are creating the object or a group in which we are storing data, after some time the size of the group automatically increase or automatically decrease when we are removing the data from the group. Means dynamically improve the size of the group and sort the size of the group according to the element inserted or deleted from the group. So same here, when we are creating the object of a hash set class without passing any argument in its constructor. So while default its size will be 16 element, we are able to store by default size. And the load factor, what is load factor? Means load factor, we have to understand that after filling the fixed some amount of some percentage of spaces, automatically Java creates a new space for the inserting the new element into the group. What I am saying, for example, I am creating the hash set class object without passing any argument in its constructor. So by default size is 16, and the load factor by default, that is called 0.75. By default load factor provided by Java is 0.75, means 75%. When 75% of spaces of 16 element is filled, automatically Java created the new spaces for the storing the element into the group. Okay. Second constructor is that is in which we are able to pass the capacity, means size of the hash set. Okay, so we are able to pass the size of the hash set object in which we are able to store the data, and its by default load factor is again say 0.75, that is 75%, filling the data, filling the space of the group. Again Java started to create a new spaces for inserting the element into the group. Third constructor is that is called in which we are able to pass the size of the hash set as well as the capacity, means load factor also. Means if I want to create a group in which I have to provide a 20 element size of a hash set, and after filling the 50% of the group, we want to create a new size of new spaces for in the same object. So that I have to pass as a 0.75 load factor as an argument into the constructor of the hash set class. Okay, so third constructor in which we are able to pass size of the what is the size of actual size of the hash set class, means hash set object. And same we have in the argument by using the comma we are able to pass the what are the load factor of this object. Okay, last constructor we are able to create that in which we are able to pass as an argument directly the object of any collection interface. Means if I want to convert the array list object or a linked list object or vector object or any other group of collection interface object into the hash set interface, hash set class object, so we are directly pass the object into the constructor of a hash set class. So this is for all four constructor of a hash set class. Now I am talking about the second child class that extend the hash set class, that is called linked hash set class. What is linked hash set class? What are the extra functionality provided by the linked hash set class? Okay, so linked hash set class is all inherited property of a linked hash set class, but some difference from hash set class as well as the linked hash set class. So the specific and a core functionality that became a hit this func method different from the hash set class, that is called the insertion order. Means in a hash set class insertion order of element is not reserved, but when I am talking about the linked hash set class, in linked hash set class, like same in list interface classes, same here linked hash set class are able to provide the insertion order is pre-reserved. Means duplicates are not allowed, null values are allowed. Each and every property of a set interface are inherited by the linked hash set class, but one property are making it different, that is called insertion order is not preserved. We are not able to store the element in the group in which order, in the same order they are inserted into the memory also. So insertion order is result into the linked hashed class. So here is a hash table as well as doubly linked list. Both, yeah, here two data structure are used for creating the class of a linked hashed class. When I'm talking about the hashed class, so hash table data structure are used for creating the class of a, or giving the implementation of a hashed class. When I'm talking about the linked hashed class, so here some step functionality, that is insertion order is pre-reserved. For that, the doubly linked list as well as a hash set, means doubly linked list as well as the hash table data structure are used for creating the class of a linked hashed class. Okay, so here are some, if you did not know about the what is doubly linked list, what is the hash table, so you have to understand the concept of a data structure. This is a part of data structure. If you did not know, so forget about it. You just focus on the topic of the video, that is called the set interface. What are the functionality provided by the set interface? What are the classes that implement the set interface? First classes is hash set class. Second child class of hash set class is linked hash set class. Both are used for storing the data into the group, but some differences between both of them. Hashed class, in which we are able to store the data where insertion order of element is not reserved. But when I am talking about the linked hashed class, so linked hashed class are different by insertion order is reserved, means in which order we are stored the element into the group. In the same order, data are stored into the memory also. So this is all information about the set interface and linked hashed class as well as the hashed class. Same four constructor in present in linked hashed class as present into the hashed class. So I'm not going to in detail about the constructor of the linked hashed class, because you are know about the what are the default size, what are the load factor are provided. We are also able to provide the load factor as well as the size of the linked hashed. And last constructor is in which we are able to convert any data structure, any collection interface object into the linked hashed class object. So thank you for watching this video. See you in next one. And in this video I covered the set interface of its classes that are directly implement the set interface. In next video I'm talking about the what are the classes, that what are the sub interfaces, what are the child interfaces that extend the set interface. After that I complete the queue set interface. Then in upcoming video I'm talking about the queue interface. So see you in next one, and thank you for watching this video.